A person of 80 kg mass is standing on the rim of a circular platform of mass 200 kg, rotating about its axis at 5 revolutions per minute (rpm). The person now starts moving towards the center of the platform. What will be the rotational speed of the platform when the person reaches its center? So this is a person standing on the rim of a circular platform rotating about its axis. Alright, the mass of the circular platform is 200 kgs and the mass of the person is 80 kgs. Alright, now the person, and it is moving at the speed of 5 revolutions per minute. Alright, now the person starts moving to the center of the platform. So what will be the rotational speed in RPM of the platform when the person reaches its center? Alright, so when the person starts moving towards the center, we know that there are no external forces acting on the system. So therefore, applying the conservation of angular momentum, we get that initial angular momentum is equal to final angular momentum. So I1 omega 1 is equal to I2 omega 2. Alright. Now the momentum of I1 is given by mr square by 2, which is the moment of inertia of the platform, and mr square, which is the moment of inertia of the man. Omega 1 into omega 2 into mr square by 2. So on simplifying this equation, we get that omega 2 is equal to omega 1 into 1.8. So let's substitute omega by 2 pi f. So we get 2 pi f by f2 is equal to 2 pi f1 into 1.8. Now 2 pi gets cancelled and we know that f1 is 5 rpm as given in the question. So let's substitute its value over here. So we get f2 is equal to 5 into 1.8, which is equal to 9. So 9 rpm is the correct answer.